Hello everyone, my name is Ty Everett. I am the founder of Unite.cache, and today I'd like to try to make a presentation to address some of the more controversial aspects of the changes that are being proposed to Bitcoin Cash for the November 2018 hard fork. So let's just try to do this thing. Canonical compromise. So this presentation primarily focuses on canonical transaction ordering, but it could be expanded to include any of the proposals that are being made. So basically, for some background, canonical ordering orders transactions by transaction identifiers instead of by the time they were received into the block. This creates some benefits as well as some drawbacks. It allows for faster block propagation using graphene, although we should point out that graphene can be implemented by transmitting order information, transaction ordering information alongside the actual block itself. But it would make graphene a little bit more efficient than it currently is. It provides some limited benefits for SPV proofs, so you can prove that a transaction does not in fact exist within the context of the current block, and it provides localization of transactions within blocks, and there are some useful things that can be done with that. Drawbacks include that it breaks current implementations of parallel transaction validation, and that it really hasn't been tested or researched as much as some people would like. So, faster block propagation. Basically, because of the way graphene works, ordering information does not need to be transferred, or if the order of transactions within a block are known, we don't need to send ordering information over the network, which can reduce the size of blocks that are being sent. The next thing it can do is it can allow for more compact SPV proofs. So if SPV nodes know the order of transactions in a block, they become able to conclusively, they can conclude that a transaction doesn't exist within that block. So if the SPV client wants to know about transaction number 7465, it then asks for all transactions using a Bloom filter that start with 746. It can then it sees that there's 7463 and 7468 in the block, and it can know that they're right next to each other because of the Merkle tree, and based on that it can know that because of canonical ordering that 7465 is not present in the context of that block. I know that transaction IDs can change because people double spend or change the order of their outputs and rebroadcast or whatever, but I really don't find that relevant because if you're going to design a system that utilizes this, granted I don't know that there's many use cases, people can add them in the comments if they know of any. I don't see that as being relevant because if people are going to design a system, then they're going to find a way to basically mitigate that. And the last thing, and I think the most useful from this, is the localization of transactions within blocks, which some people have said, what's the use case for this? And that use case is that you can separate out different protocols by transaction and then provably grab all transactions in a given block that comply with that same protocol. So the transaction broadcaster can change sequence numbers or basically any other value inside the transaction, so that and they just change it and change it and change it until the TXID for the transaction falls within a given range. Now, because of ordering, we know where the TXID would live inside that block, and because of the Merkle tree, we can request and prove that this is all of the transactions within that block falling within that given TXID range, like we demonstrated before. Yeah, it can use this to sort, token transfers. Like, let's say if you're going to transfer token X, you would have all the transfer transactions start with TXID, I don't know, 1337, and then whenever you request a block, you can request all transaction IDs which start with 1337, and then you can then provably validate that those are all of those transactions within a given block, which can allow for some useful transaction filtering, allowing for sort of SPV functionality of tokens. But yeah, basically that SPV, yeah, they can provably know blah blah blah. An example would be that if memo.cache transactions had a transaction ID that started with 60 blah blah blah, that basically, and yeah, that transaction ID would be accomplished by just brute force, basically just changing something using either sequence numbers or nLockTime or whatever it is. Well, not nLockTime, but we'll get to that in a second. Then any SPV nodes that implement memo protocol, or like SPV clients, they could request the block and just grab all the relevant memo transactions from that block using a Bloom filter and provably know that no transactions are being withheld from that block at least. So I think that could be useful. But now we'll move on to, whoops, where did I go here? Okay, compromise. So basically here's what I'm proposing as a compromise. So everybody can acknowledge that not all parties involved with Bitcoin Cash want to see this change happen, and for good reason. There are a lot of headaches that are going to happen with parallel validation. There's a lot of really unknowns with how it's been implemented, and different ways that it's been implemented. There's the Gavin Andreessen proposal and the ABC proposal. So I think that miners should be allowed to use canonical ordering in a block if they want to, and the reason for that is that graphene would work better, and it would, if they're going to do this, miners should be allowed to use canonical ordering in their blocks, and they should not reject blocks that don't use canonical ordering. So if miners who use canonical ordering, they should just pick a block version different than the current one and use that, and that way nodes and everybody can know what consensus rules to enforce for that block. So like they can't just use the canonical ordering version and then not implement canonical ordering, or else their block's invalid. And with topological ordering, they just use the current block version. Blocks with the new version should therefore, that's basically what I just said. Transactions that only want to be included in blocks that enforce canonical ordering. So this is pretty useful for something like memo protocol or what have you. If you're creating a transaction that only wants to be included in a block that uses canonical ordering, then your sequence number should be, your nLockTime for all of your inputs needs to be uint max -1. And there might be a better way of doing this that I just don't know about. Maybe there's a transaction version or something. I'm not too familiar with the ins and outs of it, but a way that you could do this is just set the nLockTime number for all inputs of the transaction to be uint max -1. And that way, and if anybody includes a transaction in a non-canonical ordered block, so the current block version, with a sequence number of uint max -1, that block is invalid, right? So if you're malicious and you want to use a non-canonical block to include transactions which want to be included only in canonical blocks, then your block is invalid, and you get forked off. So those would be the consensus changes that would allow for this sort of compromise to happen. And I really think that all nodes, all nodes are going to need to validate this. So if a node comes across a block with this new version, then they need to validate canonical ordering and throw out any of their parallel validation rules for that block. But the thing is, if miners believe their use of canonical ordering will reduce their orphan rates, it will be in their best interest to use it. If the value, if they value the benefits of parallel validation more than canonical ordering, then they can use topological ordering in the current block version instead. This creates a direct monetary incentive for miners to pay developers to implement better validation techniques with canonical ordering. So the faster that they can validate the transactions that they receive from canonically ordered blocks, the faster they're able to move their mining hardware over to those new blocks, and thus they make more money. So miners are incentivized to pay developers to come up with better solutions, regardless of whether this breaks parallel validation for these types of blocks, in order to basically make more money. If the number of blocks that use canonical ordering in the past 4,032 block period, so like around a month, exceeds like around 90% or so, it could be made necessary. This would indicate that the market has decided that it would be a useful and valid addition to the Bitcoin Cash protocol. That would be completely optional. I don't know whether BCH, the community developers, would even agree to want to do something like that. But I think that it would be a useful addition. And this does sound similar to like a soft fork, but it's really not a soft fork, because if a node doesn't implement canonical ordering for, if a node doesn't implement canonical ordering for when they stumble across a block with this block version, then their validation rules will reject the block and maybe not even parse it correctly. I don't know. But anyways, it would be invalid, and so that node would get forked off. So I mean, correct me if I'm wrong on this, because I'm kind of starting to question it, but I believe this would be a hard fork change, seeing as nodes themselves would not want to accept the canonically ordered block, even with a different block version. So token systems and other applications can still make use of some of the benefits of canonical ordering without complete consensus, provided that node implementations can agree to validate canonically ordered blocks if the miner of the block explicitly states that their block is canonically ordered, and thus those validation rules should apply. So that's really that's my proposal, and I really think that we as the Bitcoin Cash community need to sort of devise a way that we can resolve this chain split thing, because this is getting, in my opinion, a bit ridiculous. Opcodes, I think we're going to need to talk about opcodes at a different time, but I don't think that a few opcodes that already are being planned on being implemented in May 2019, I don't think that should be reason enough to split the network. I think that the work that everybody has done on adoption and getting merchants and infrastructure and everything rebuilt over this past year on this network, I really think it's too valuable to throw away over a few opcodes and some people's ego. We need to implement things in a way that people who disagree can disagree, but if miners want to do something, they should be able to do it, and all nodes should respect that. I mean, unless they want to, change the limit or change the coin supply limit or allow double spends, but if miners want to, miners should be able to order transactions within their blocks however they would like, as it's their blocks, and if they want to explicitly state that they are ordered in a certain way, then we should just validate those specific rules for that miner. or for that block rather. So that's my sort of proposal here. This is my very first time doing a presentation in this style or on this so in this field, I guess, to this community. So let me know if there's some glaring thing that's missing. But I look forward to any feedback that anybody may be able to provide, and I really hope that we can resolve our differences and unite under this one currency that is really going to hopefully benefit the lives of lots of people around the world. So thank you for watching, and I look forward to your feedback.